Hey, how's it going, guys? Welcome to the complete starter tutorial for my add-on PaintKit, which I just released on Gumroad and should be on Blender Market sometime soon. PaintKit, as the name suggests, is a custom-built tool set designed specifically for creating stylized painterly looks, while also focusing on ease of use. It may take a minute to get the hang of all the controls, but stick with it and you'll find yourself at home in no time. Now for a little background on the creation of PaintKit. I've been looking into stylized shading for a long time now, and have been particularly fascinated with the looks of the Windshield Wiper, Puss in Boots, and TMNT Mutant Mayhem. I was actually lucky enough to help make promotional materials for the movie with my friend Peyton, and in the process was able to actually see the production models and learn a lot more about how big studios create these looks with their pipelines. And that's a key point here, pipelines. PaintKit has been designed so that almost any asset you make can have their effects applied and baked so that you can use them in any other 3D package. This also means that any of the textures and shading effects that you make will work in both Eevee and Cycles. Now with all that out of the way, let's jump into how to use PaintKit. So here we have a default scene, and I just added a plane so we have some ground reference. And installing PaintKit is super easy. You just go to Preferences, Install like any other add-on, but importantly, make sure that you restart Blender before trying to use it. Otherwise, none of the node groups that you will need will be in the Blender file. So with PaintKit installed, the first thing we'll go over is the menu available to you in the end panel of the 3D viewport. So if I go here, and I scroll down through my long list of add-ons, we can select PaintKit. It's very simple. The actual interface isn't a whole lot because I'm not great at coding Blender add-ons. This is my first time doing it, so if anybody runs into any bugs of any sort, please let me know. It would help me a lot. So now looking at our panel here, the first two things we want to make sure we understand are Add Brush and Add Guided Brush. So going over this panel a little bit, the first two buttons here allow you to either generate the default brushstroke set, which essentially just generates a bunch of randomized cards on your mesh that you can then texture to mimic brushstrokes. When brushstrokes are added to an object, you will get a menu in the panel allowing you access to all of the geometry nodes controls of the brush. The brush is a separate object that is parented to the original, which contains all of the geometry node effects. So if I go here and I click Add Brush, we can see we have a bunch of planes instanced onto our cube here, and I will turn on wireframe so you can see these are just cards. These are literally just planes with a bit of subdivision, and you can change the subdivision by changing the card resolution. And I want to go over the controls over here because they're a little hard for me to format as an add-on, but I want to keep improving it. But for now, this is what I have. So starting at the top, we have Expand Surface. What this does is this expands the actual surface that they are generated on. So if you have a cube, it will then expand the cube and then place all the cards onto your object. So I'm going to set that back to 0. And a big thing that I wanted to work on with this add-on is control. I want you to be able to have a lot of control over what you're doing instead of a one-click solves all your problems type add-on. So then we have Density Max, which is our actual density amount. And we also have Density Factor, which is the factor of the actual point distribution. So if you wanted to improve performance, you could say, have your density max at 26 and then reduce it and then bring it back up when you need. And now there's also frame increment. This by default is set at 0 because it's a very specific use case, but I find myself needing it quite a bit. What frame increment does is it allows you to set a increment for how many frames should go by until it changes this distribution seed. So say if I wanted to mimic something in more traditional media style and animate it on 2s, I can set the frame increment to 2, and if I hit play, we're having it change on every second frame. Now I can pause that, change that to, let's say, 6. So now every 6 frames, it's changing. Super useful if you want to use this in a stop motion style or even just something with a lower frame rate and you don't want the cards to just generate randomly on every frame, because obviously that would ruin the look. So I'm going to set that back to 0, which means it just won't change at all. And then we have Generation Seed, which is kind of a subset of frame increment. This is just the seed that it intakes for where to distribute the points, so you can change that if you want a different output for whatever reason. And then there's Expand. This actually expands the cards after they're generated. So we're not expanding the base mesh that we're using, we're just moving the cards away from the object. And then here, both these object inputs are something that you won't really have to touch at all. All they do is selecting which object it's actually getting all this data from. Material is currently grayed out. I'm not sure why I can't change it. However, It's just taking the material of the object that you're generating brushstrokes on. And I've built PaintKit so that you're able to use the same exact material that is already on your existing object, so this shouldn't be much of a problem. And then here we have subdivision. Subdivision is a little similar to the card resolution, although it's subdividing it after the shrink wrap modifier that you'll be able to apply, which can help you smooth out some of those rougher edges when it starts to shrink wrap onto the surface. However, do be careful with this because this is the same as the subdivision surface modifier, so I did crash Blender when filming this tutorial because I typed a way too big a number in. And then here we have noise increment. This is the same thing as frame increment, although what it does is instead of changing the generation seed, it's changing the position of the noise that is actually affecting the cards. And you can adjust how much this noise affects the cards by changing the noise factor. And this is just a simple geometry nodes noise texture, so you can change the scale and the seed of the noise. And now just for an extra example, if I set the noise increment to 6, we can see that the noise is changing on every other frame, or every 6 frames. However, it's not changing the actual generation of the cards. And by default, noise factor is set a little bit up, just so that these cards don't constantly overlap directly into each other, which would cause Z-fighting and problems in your render. And now if I wanted to remove these brushstrokes, I can just hit remove brushstrokes and it will be removed from the object. I can also, when I'm using this, if I want to increase performance, I can hit hide or hide all, which will hide all the brushstrokes in the scene instead of just the one that you have selected. I'm also going to show you add guided brush, which is currently in beta, so it's not perfect, but it works most of the time. What add guided brush does is when you start, it will look like nothing, but what you have to do is you will hide those. And if you create a curve object, I'm going to create a Bezier curve, I'm going to delete those curves in edit mode, that's important. And then I will hit the draw tool. And if we choose surface, we can actually choose how we want those strokes to flow instead of having just completely randomized strokes. So if I draw some more guide curves here, I'm just going to draw them at random, maybe have them go this way. And the more guide curves you have, the better of a result you'll get, just because it's based off proximity. But if I go back and then I unhide my brush with the object selected, we can then choose our guides, which are the Bezier curves, and we can see that they're now following the tangent of the curve. This isn't the best in this case because the tangent of the curve is kind of moving through the object, which is why I'll go over this shrink wrap toggle with this as well, because shrink wrap toggle just allows you to toggle the brush strokes being shrink wrapped onto the object. And this happens before this noise is applied so that the noise factor can still be used after the shrink wrap. And now this also ties into the subdivision setting, which you can see happens also after the shrink wrap, so it'll smooth things out a little bit. Now currently these cards are way too big, so we'll reduce their size and maybe reduce the noise factor. And it's also a very sharp object, which I would recommend against using this type of thing with. Typically degeneration works best on smoother objects just because of the shrink wraps onto completely flat corner geometry gets a little odd. And you can also use the simple shell option, which I will show you in a second. So if I just go ahead and I smooth this object out a little bit, we can see that now all of our brushstroke cards are actually following the Bezier curves that we drew. So here it's kind of going this way, and you'll get a bit of issues if you suddenly have two curves that are going completely opposite directions that are in the same spot, because the brush generator won't really understand where it wants each of these strokes to go. So the important thing to remember here is have more brush strokes than less, and also have them very smooth and kind of continuous. So I'm going to delete this curve here and remove brush strokes again. And there is also a add simple shell option. So now if you're having any sort of performance issues, or it's just a very heavy thing to handle on your computer because it is generating a lot of card instances and sometimes they can need a lot of geometry, you can use the add simple shell button instead. So with add simple shell, all that does is it quite literally adds a simple shell object of your object on top of the original. Now, this will only work if you're using the simple shell node group that I will show you in the shader editor. But it has all of the same controls that you would want in the, but it contains all the same controls that you would need but it contains all the same controls as the other brush generator, including noise, noise scale, noise detail, shell count, and an offset multiplier just for how much each but it contains all the same controls as the original brush generator. The only difference is that it also has shell count, which can go up to 3, so you can have up to 3 different shells on your object, and the offset multiplier, which then changes how much each successive shell is offset from the object. So now with the main panel out of the way, we can jump into the shader editor. So now this is the example blend file, which I will package with the add-on so that you can see all of the things that you're able to do with it. And in here, I have all of the node groups that you will need to use PaintKit. And here I have them organized into groups of kind of what each of them can do. So the first thing I'll go over is just the shaders. So I have 3 shaders here. 2 of them work with cycles and 1 works with only Eevee. Now you don't have to use these shaders to use PaintKit. PaintKit is usable with any shader that you use as long as it has a color and a normal input. The only difference with these is that some of them can add a bit of extra flair that you might not be able to get with just a regular diffuse shader. So starting with these cycle shaders here, because personally they're my favorite, they are based off of the Toon BSDF that's included in Blender cycles. Now the only difference with them is that they are then layered on top of each other so that you can get really interesting cell shaded like effects that you normally wouldn't be able to get with a diffuse shader in cycles. So here we have C-Toon Diff, which is diffuse, and C-Toon Glossy. Each of these I will set to an actual color so we can see their effect. You can see with the C-Toon Diffuse, we actually get some rather nice cell shading. You can smooth that out if you so choose, which will then kind of mimic just your regular diffuse shader. And you also have a shine factor on the diffuse, which just lets you control this final highlight that gets added, because sometimes on certain objects it can almost look like a gloss highlight and you may not want that. Now looking at C-Toon Glossy, I'll just copy that color. It's the same thing, although the Toon BSDFs are now changed to glossy for the last 2 of the layers. And this kind of mimics a much more shiny appearance on the object. And there's also a metalness slider, which isn't necessarily the most accurate, but it is based on the idea that metal objects will actually reflect a tinted reflection instead of just a white specular reflection. And you can use that to your advantage here, whether you want the Toon object to look kind of like metal, or if you just want more color in the actual glossy area of the object. You also have a kind of rudimentary roughness control here, and you also have the same smoothness control as the diffuse. Now hopping into Eevee here, we'll take a look at PK Sketchtoon. So Sketchtoon is a shader that is kind of supposed to mimic a very sketch-like or almost crayon-drawn appearance, and there's a lot of different settings in this. Now currently I'm working on improving the UI of this node group because this is the first one I made, but I think it can still be very useful in its current state. So here, the first couple controls we have are for the glossiness. Now you can turn it all the way off or all the way up, and we also have glossy min and glossy max. What this lets us do is you can see it's changing the actual range in which we get glossiness. So you can actually tighten this up really hard so that we get really, really tight tolerances on what will be glossy and what will not be, which can really be helpful if you want a really tight Toon-ish specular highlight on an object. You also have roughness controls for the glossy shader, and you also get gloss normal strength, which changes the normal offset only for the glossy part of the shader. You also get gloss color just to change the color of the reflections. So if I set it to blue, you're gonna get a colored reflection. So now if you look here, we have shadow HSV and multiplication. This is just a slider letting us choose which option we want to use. And what this lets us do is this lets us change the color and tone and intensity of our shadows instead of having Blender manually figure out the shading for us. So if I look at shadow HSV adjustment, what this will do is this uses the hue saturation value node, and this is just giving us external inputs for that. So now the best way I've found to use this is just manually setting inputs, which is a little weird at first, but that's just the only way I've found to get this to work really nicely. So let's say we wanted our hue to be shifted more towards the cool side of the colors when it gets to the shadow area. We can just move this hue slider and it starts to affect our shadow areas the way we would expect. And we can also turn down the saturation of that area or turn down the value. Now with shadow HSV or multiplier setting set to multiply, what this is going to do is this is going to use a multiply mix node to actually decide the color of our shadow. So I can multiply our original color by whatever this is to create our shadows. And this lets you get a little bit deeper with the color, and you can also input into these so that you could have either texture driven inputs or use manual inputs to override like higher numbers than you would normally be able to with just an RGB. Now I'm gonna set this to something like dark blue for now. Now looking down here, we have normal strength and normal noise scale. These are two settings that will affect the actual normals of your object's shading. Now, without getting too in depth about what normals actually are and how they operate, the main idea is that the normals are getting the shading info, so they will decide how are we supposed to be shaded given if we're facing the light or the dark. And all this does is offsets that information using a texture, and then we can use that to start kind of breaking up our shading a little bit and making it a bit more interesting. Now we also have normal noise scale. That just allows you to control the actual size of these patches that the normals are getting broken up into. And I usually like to keep it somewhere around like 5, maybe up to 20. So now I'm gonna reset these just so we can see these shadow controls, because we also have shadow min and shadow max. Now, just like the glossy controls, what this does is this lets us set a very tight boundary for what is in light versus what is in shadow. It works the exact same way as the glossy controls, it's just controlling your shadows. We also have frame increment, which works the same way as the brush generator. We have paint color lin light, which is just a linear light multiplication of the paint texture's color on top. Sometimes it looks good, sometimes it doesn't. It's a crapshoot. Now we also have paint texture overlay, and we can change the actual intensity and color of this overlay by using this slider here. And we can keep it by default by just keeping it in the middle at 0.5. Now here we have some Fresnel controls, which allows us to actually add a bit of a Fresnel kind of rim light effect onto our object. And we have controls like Fresnel blend, we have Fresnel limit, and our actual amount that we're using it. And this also responds to the normal offsetting settings that we have up there. So if I were to turn the normal noise scale up a bit and turn up the normal strength, we can see that the rim light is also getting offset by those normal offsets. Now turning off the Fresnel, we're going to look at splotches HSV. This is a similar controller to the HSV slider that we used above to control our shadows. This just controls the splotches hue, saturation, and value. And these splotches are just basically a big swath of splashes that get splattered onto the object procedurally. And these splashes are just exactly what they seem, splashes that are mapped in window space by just applying it straight to the object. It's just a multiplication that can give you a little extra detail in your render. And you can also turn off your other options and it can kind of almost look like a marker. Now, paint texture scale is the actual scale of this paint texture that is overlaid on top of everything. And we also have a streak scale for getting a bit of offset on that texture, because if I set this to 0, by default, our texture is getting scattered with a Voronoi noise, and usually I like to break that up a little bit. And we can also control the streak effect. So that's just how much it's actually streaking. And then we have bump strength, bump distance, and bump height. Those are your regular bump map controls. So now with those two big shaders out of the way, let's go and actually look at the fun part of this add-on. So now with the main shaders out of the way, we can actually get into what makes PaintKit PaintKit, paint release shading. So I'm just going to use this diffuse shader here. I'm going to set it to something like red. And currently I'm in Eevee. This will work in both Eevee and cycles. Our primary use here will be Normal Painter. Normal Painter allows you to create painterly normals, as the name suggests. So in here we have a few controls, like our factor, that's just how much our normals are being affected, our paint stroke size, so that's kind of the amount of division that we're getting for each shaded area. We also have paint smooth to kind of smooth these things out. And we have paint roughness, which will kind of roughen up the edges between those things. And we also have a roughness scale. So now turning down the roughness, I'm going to bring in a custom texture because that is what this input is for. And here, let's use a Voronoi texture. And I'm going to set this to Chebychev. And I will plug that into the custom texture. So now our normals are getting really, really messed up. But it's very interesting and kind of a very graphic look. So if I view the diffuse BSDF now, we can see that we're getting normals that are offset, but it's very kind of graphic. It's a very interesting look, and we have a lot of control over our normals. So now custom texture can use any sort of RGB input. My favorite is just to use an image texture that actually is of the painting. And then down here, you just have your usual controls for bump and normals, and this is just a slider to tell it that you should use this custom normal input if you so choose. And you also have a seed control just for the seed of the actual noise itself. Now I'm going to delete this and I'm going to show you NP controller, which this is just meant to be directly plugged in to all of the same inputs just by name. And what this is for is you can use this node group to actually use this frame driver, and this will allow you to make kind of global changes to any material because each node group is an actual instance of the master node group. Now what that means is you can see this little 4 here. That means this is being used 4 different times in other materials. So if I were actually using multiple materials with these controls, you would actually be able to see if you control things inside of the node group, it will be global. So you won't have to do all of these normal painter adjustments on a per object basis because sometimes you can have a lot of objects with a lot of shaders. And if you want them all to use the same custom normal settings, you can just use this node group. So now with normal painter covered, we're going to look at the procedural brush textures. These are a bunch of different procedural materials or textures that I have made that kind of simulate different types of brush strokes. Some of them can be pretty performance heavy, and I highly suggest that with any procedural texture, when you're done making the asset, you should bake all of this down into just a texture map. It will make your shaders load a lot faster, and it will just be a lot less performance intensive overall. So looking at acrylic stroke here, we have a base color input and hue, sat, and val variants. Now this allows you to vary on a per stroke basis the saturation, hue, and value of your brush strokes. So let's say I have super dark red and I want the brush strokes to slightly change in hue and maybe also be a little less saturated in some places. We get a really nice effect. Now I'm going to plug this into a diffuse just so we can view that a little better. So down here we have stroke scale, we have stroke randomness, which can get a bit messy if you push it too far, but it just helps break up the evenness of the strokes. When you have it set to 0, they're very straight. Stroke randomness just lets you add a bit of randomness into that. Then we have some edge controls. These are the same type of controls as here, except these just affect the edge of the paint strokes. So what this is meant to do is kind of mimic when you're drawing something with an actual paintbrush, you will get a little bit more buildup of paint along the edges. So you can turn down the value a little bit and maybe increase the saturation, and that can kind of look like you have a bit more paint built up on those areas. Now we also have a splotch setting for this one. This one we can just set the multiplication to whatever we need. And we can also change the scale, detail, and roughness of the splotch mapping, but I don't always use this. Now, by default, all of these procedural textures are actually box mapped instead of just your regular object coordinate mapping, which is really beneficial when you're trying to make a texture like this, because you're not going to be able to get this kind of stroke displacement on these procedural textures without first mapping it to a flat area, and a UV is sometimes unreliable and can have very apparent seams. But if you don't want it box mapped, you can turn this off and it will use UV mapping. And you also have blending. This is the same as blending when you use an image that's box mapped. And you also have rotation, so that each of the sides that it's being projected on gets rotated a little bit differently, just to add a bit of extra randomization. You also have a W value, which is kind of just our seed, and you also have normal intensity and patch scale and smooth. That's the same as the other controls, and it allows you to use this as a normal output to get all of the shading effects of the paint strokes into the actual normals of the shader. So you can see with the normal plugged in, we are actually getting some normal displacement based on this procedural stroke texture. And we can adjust the intensity of that. We can adjust the patch scale, because this is actually based on the same patches that we get with normal painter. And you can also change the smoothness so that we're getting some more sharp breakup, or we can have it a lot smoother. Now this one also has a displacement, and this is meant to be used as a displacement for any image texture that you might use that you still want displaced by brush strokes, but you don't necessarily want to use the actual texture. You can plug this into the mapping, and these are just random values per brush stroke to kind of offset your texture a little bit. And I have an example over here of that working. That is this object. This is just a traditionally UV mapped object, but the brush strokes are offsetting our texture here. If we use the acrylic stroke displace, which is just a smaller version of acrylic stroke plugged into the mapping, you can see that we're actually getting our image texture displaced by these strokes. So now returning to our procedural textures, we also have dry brush. So now dry brush actually mimics exactly what it says, a very dry and rough paintbrush. And we have similar controls as we did with the acrylic stroke, and we also are getting a normal output out of that, which we can adjust the intensity of and the patch scale. We also have hue, saturation, and value controls. So we can change how the hue or saturation and value are being offset on each of these. And this one actually has saturation and value bias, which lets us, if we turn up the saturation here, we can see that it's kind of pushing it more towards the desaturated side, just perceptually. So we can turn up the bias a little bit to kind of offset that to make it appear more visually correct. And the same thing happens with the value bias. If we turn this all the way up, we can see it tends to get a lot brighter, and we can turn up the value bias to just kind of choose where we want that middle ground to lay. And next here we have watercolor. Watercolor is meant to simulate watercolor. Now we have detail and roughness controls for all of this noise, and we also have a scale, and we can also do hue, saturation, value shift, and shifting our contrast a little bit. Now we also have watercolor normal, which is only the normal component of this shader, which can make things a little faster if we only need the normals. Same thing with acrylic stroke, and we also have acrylic stroke displace, which is just the displacement output over here. So now with the procedural brush textures covered, let's go into the effectors and tools of this add-on. So now moving into the effectors and tools, these are just kind of a grab bag of different attributes that you can access for brush cards or just tools that I've found useful. So starting off here with simple grass is exactly what it says. It's just a very simple grass texture. Now graphic effect over here is just a procedural texture. It's very simple. It just allows you to have a very graphic, kind of very hard edge offset to some of these normals and textures. And you have scale and detail controls over here. Now box mapper is actually kind of special to me just because it's super helpful for making your own procedural textures. And what it does is it allows you to box map any procedural texture that you have. So if I have a noise texture here, traditionally it would be kind of difficult to do this, but if I turn up the blending here, you can see that instead of having to do object mapping with our noise textures, we can actually box map it now, which will allow us to do a lot more different effects when it comes to mapping the textures and all that. And then here we have normal transfer. And then here we And now here we have HSV Bender, which is exactly what it says. It just allows you to control the hue saturation value of something. The only difference is that this allows you to use a texture input. So here we have HSV Bender. HSV Bender is the exact same as the hue saturation value node. The only difference being that you can actually drive it with a texture. So if I plug graphic effect into the texture and I turn up the saturation, for example, we can see the saturation is now being kind of controlled by this texture. We also have saturation bias and value bias as discussed in the dry brush texture. Now, normal transfer starts to get into the weeds of the actual brush card generator. And what this allows you to do is this allows you to take anything that Geometry Nodes has instanced, and it allows you to transfer the normals of the base object to the instances. And my favorite thing to use this is in Eevee with grass, because you can see our grass here looks very nice. But you can see if I take the normal transfer and I cut that, we can see by default, this is how Eevee would render this. Now, if we just transfer the normals of this base plane to our instances, we get much nicer shading, and it gets rid of a lot of those ugly shadows that you see a lot. So now moving back to our example here, we can go into the brush gen tools now. Now, all of these are tools that you will probably be using when you start using the actual brush generator. So I will give this sphere a diffuse material, diffuse, and I will bring this over here, just as our example. Now, when you first add a brush, it's just gonna look like this. These are just plain cards that are sharing the same material as your object. Now, of course, this doesn't look very painterly, so how can we change that? So the first thing we could do is we could actually make a mask for these and add a brush texture to them. Now, if I use add brush text, this will just go at the end of our shader here, and this will serve as a mask that can drive the transparency of these objects. So if I go to our material, I will enable alpha clip and alpha clip. Actually, we'll use alpha hash since that's a little more accurate. We can then bring in a texture of our choosing. I'm going to use an image texture of some watercolor that I have here. We'll use this one. So currently with this plugged in, we don't see anything. Now, there's two problems here. One, our mask isn't sharp enough, and two, we don't know what UVs we're using. So how do we tell the brush generator what UVs to map this onto? This is where brush attributes comes in. Brush attributes is a controller that allows us to see the UVs of cards or the UVs that they are sampling from the base object. We are going to use the cards because each of these cards just has a very basic UV attached to them. And then we will plug that in right here. So now if we just view that, we can see that now these are all being mapped properly. And I will reduce the card size so we can see that a little bit better. So now that's being mapped properly. Sometimes you may have to add some mapping here and just rotate it along the Z by 90 degrees just to change the direction of your strokes. But for the most part, it usually just works right off the bat. Now looking back at the end of our shader here, we can see we're kind of getting an effect. And if we just throw in a color ramp in between those, set it to constant so that we'll now get a very sharp output, we can bring this down until we start to see our brush strokes. I like it right about there, so I'm going to view that using Control-Shift-Click, and we can see we're starting to get brush strokes around our object. Now what Exclude Shadows does is this just excludes the cards themselves from being able to cast shadows in both Eevee and cycles. And you can just plug this at the end of your shader graph. So now looking at this object, I like what I have here. I like the brush texture that we have, but the cards are looking a little flat. I would like them to kind of look more like they're contouring the object. And instead of using the shrink wrap toggle, because I still like the offset that they kind of give to the edges, I'm going to add a sampled normals node. Now this group just lets us sample the normals of wherever the card is on the surface and use those normals instead of just their flat plain normals to shade themselves. So if we plug this in, we can see that our shading has gotten a lot smoother. Now they're not curved, but they kind of shade like they are, so it gives a bit of a smoother appearance to it. And if we turn this off, we can see that it's really apparent, especially along this gradient here. So now moving along with our brush generation, let's say we also don't want to see the back of these. What we can do is we can actually add a backface culling. So PK backface culling, and we'll just put that there. And this just does the same thing as Eevee's backface culling option. The only difference is that it's in your shader graph and it also works in cycles. So now we're in cycles and we can see it looks just how we expect it to. So staying in cycles here for a second, I can show you cull diffuse. Now what cull diffuse does is it's very similar to backface culling. However, the only difference is that it's just going to kind of cull out this diffuse bouncing that we get, but it's not going to kill the actual backface appearance. So we can still see the back of these cards. However, it's kind of flipping the normals so that the shading remains the same on both sides of the card. So that on places like right here, where if we just turn this on, we can see that even just excluding shadows, especially in cycles, we're still getting some bouncing off of the diffuse. This will just make sure that that does not affect the object at all. And it also still lets us see a bit more of the brush stroke than we normally would be able to with just backface culling. So now these nodes here are kind of your basic setup into getting your add brush strokes or add guided brush strokes options working. And now I'm gonna go over to the performance-friendly alternative of add simple shell. So now simple shell is a more performance-friendly alternative to add brushstrokes or add guided brushstrokes. It won't instance a bunch of geometry. All it will do is add a shell object, or basically a glorified solidify modifier, onto your existing object. So if I click add simple shell, I have all of my controls for the shells, and I also have shell count and a offset multiplier for how far they can go. And I'm going to turn my shell scale down a little bit. And I'm going to bring in the PK Simple Shell node. And I'm going to use the same shader for the base and for the shell. Now here we have Shell Mask. Shell Mask is actually what's going to drive the transparency between the mask and the shell. So if I add a noise texture here and plug that in, you can see a bit of the effect happening here. I'm going to plug in a color ramp just to tighten that up a little bit. Do this. Actually, I'm just going to set it to constant and turn up the detail and the roughness a little bit and turn down the scale. Now, if I turn down the shell scale a little bit, you can see if we were using an actual more paint-based texture, this kind of does look like the brushstroke generator. It's just a little bit simpler and it's much more performance friendly. So now simple shell is simpler and you don't have to do all of this exclude shadows, cull diffuse, and all that. It kind of just works off the bat. Now the only thing extra that you can use currently is shell attributes. Now shell attributes lets you take the normals of the original object and place that back onto the shell. Currently, that doesn't seem to make much sense. However, if we increase the shell noise and maybe increase the noise scale and the subdivision, we can see we get really weird shading when you start to kind of offset it. And now using the shell normal, we can actually smooth out that shading here. So it kind of shades itself a lot better. However, do be aware that now we actually do have some pretty dark areas because those normals are no longer backwards. So now using this normal input from shell attributes, we can see that it gets a little funky on the backside, but it does smooth out the shading in general of most of the visible surface. And the way we can fix this backside error is currently we can just use the backface culling node, and that will take care of that problem for us. So with all of that explaining out of the way, we've now covered everything you need to know to get yourself started using PaintKit. So now here I have an example file of what you can do with existing assets that you already have with PaintKit. And I will be including this and a couple other extra files just to get you started with PaintKit included in the download. Thank you very much for watching. Thank you so much for watching. If you've made it to the end here, thank you so much for watching. Please like, subscribe, and comment just to keep up with all the PaintKit updates and all the other tutorials that I'll be putting out, because I'd like to put out a lot more tutorials on how I actually made these things. So yeah, thanks for using PaintKit, and I hope you have fun using it.